Okay, so in the last class we have started with three-dimensional geometry, and we have derived the relationship between the direction cosines, and we were talking about direction cosines and direction rules of a line, and then direction cosines of a line passing through 2 points. That also we have discussed. Okay, so direction cosines of a line passing through 2 points, like x2 minus x1 by square root of x2 minus x1 square. So that using that you have solved some numericals. Okay. Now then we'll go to the next like here because it is three-dimensional, it is very little bit difficult to draw it on the plane and draw it on the board and derive it. You should understand the concept by referring the book. But what I will do is I'll try to put down, I'll try to summarize some of the main formulas which you need to write on your white paper and in whiteboard and memorize it.
Yes.
Okay. So that is important because it is difficult to draw a 3D in a board. Okay. So let us try to find out what are the major formulas in three-dimensional geometry. First we'll start with the plane, a line. Then we'll go to the plane. Okay. I'll do it quickly. Okay. I'll just summarize some important formulas. Okay.
Yeah.
So equation of a line passing through a point and parallel to a given vector b. Okay. So you may someone may ask you to find the equation of a line passing through a point parallel to a vector. Okay. So a line, just if you give a point, it can orient in any direction. You cannot get the direction of the, you cannot write the equation of a line. With 1 point you can never write the equation of a line. With 2 points you can write the equation of a line.
Yes.
But if you are given 1 point and another vector about which it is parallel, then you can write. Okay. Suppose let me have a point. Okay. And let me say there is a vector. So that means if this is a vector and this is a point P and this is a vector V, then you can write the equation of a line passing through this, because it is parallel to that vector. So it is passing through this point and parallel to this vector.
Yes.
Okay, so so when you write the equation of a line, always and that through in 3D. Okay, when you write the equation of a line that through in 3D, always it will be in terms of x, y, and z. Okay, because when you write the equation of a line in 3D, you will write it in terms of x, y, and z. Okay, suppose if you at any point means you will replace the coordinate of x, y, and z, right?
Yeah.
So you means any line in 2D, you will write in terms of x and y. Okay, x and y are the unknowns. So at any point you just replace the coordinate of x, y, you will get the equation of line in 2D.
Yes.
Similarly, you replace the at any point you replace x, y, and z, you get the equation. Okay, so there are some derivation is there, but without going into the details of the derivation, I will just write it. The equation is x minus x1. Let's say this point P is nothing but x, y, and z, right? So the equation of a line passing through point x, y, z
And
is
parallel
parallel
to vector
to vector B is equal to x minus x1 by L, y minus y1 by M, z minus z1 by
N.
Okay. So this is the equation of a line passing
divided by
through
the
a point
directional
parallel
ratio.
to a vector v,
Direction
and
cosine.
the vector v will have a direction cosine L, M and N. Okay.
Yeah.
So let us solve a numerical which will help you to understand it better. Okay. Okay, find the Cartesian equation of the line through a point this parallel to vector this. Okay, so let us say the vector v is the numerical he has asked is the vector v is 3i plus the vector is 3i plus 2j minus 5k, right?
Okay.
3i plus 2j minus 5k.
And
Let us say
take a
this is
point.
let us say this is the vector 3i plus 2j minus 5k. So this is the vector. Okay.
Okay.
So if I then it is passing through which point? This point is 5, 2 and minus 4. That means I know my x1, y1 and z1. So x1 is 5, y1 is 2, z1 is minus 4.
From that vector, we'll find direction cosine.
So with the vector you can find your direction cosine. So
Cos alpha.
direction cosine L is equal to 3 by 3 square plus 2 square plus 5 square. Right?
Yes.
This become 3 by 9 plus 4 plus 25. Right?
Yes.
Right? So
20,
this become 3 by 38. Okay.
Understood.
So then your
Equation.
m become this is 3
2 by root 38.
2 by root 38, and your n becomes
Minus 5 by root.
minus 5 by root 38. Okay. So you know L, M and N. So what you can do, this is let us say equation 1. Okay. So this is your equation 1. Okay. This is your equation 1.
Okay.
So in that case, replace L, M and N in equation 1. What it will become? X minus x1. Okay. This is not writing properly. Okay. Let me. So this becomes x minus x1 by L, which is minus 3 by root 38. 3 by root 38, right? Then y. So this x1 I have already found out as 5, right? Clear?
Yes.
Then y minus y2, y1 I have found out 2,
Yeah.
right? 2, then m I have got 2 by root 38. Okay. Then z minus
minus 4. Z plus 4 is
z plus 4 divided by n is equal
minus
to
5 by root 38.
minus 5 by root 38. So what is happening here? Because root 38 is common. So this root 38 will go to the numerator and it will
Get
cancel out.
everywhere.
So it will get cancelled out everywhere. So it will become x minus 5 divided by 3 is equal to y minus 2 by 2 is equal to z plus 4 by minus 5. Okay. So this is your equation.
This is some
Okay.
Cartesian form. You are telling it is Cartesian.
Yeah, so this is the equation of a line passing through a point,
And parallel
passing
to
through a
given
point
vector.
and parallel to this vector.
Understood.
So if someone asks, so rather than deriving it and going into the complication at this point,
Doing a
just
numerical.
remember this, with the help of a numerical you can appreciate it much better. Okay.
Understood.
So the catch here is find out the Direction
ratio.
cosines.
Direction
Direction cosines. So L is so L, M and N you have to find. So L is x component divided by
root
magnitude.
of x square.
M is y component divided by
Magnitude
magnitude.
of vector.
N is z component divided by magnitude.
Magnitude of
Okay. So you can take a picture of it. So this is one numerical. This is an important numerical. Okay. So it can come. One such numerical can come. So then. So just it's all about remembering this formula. It is all about remembering this formula. So first, the catch is you cannot define the equation of a line without 2 points. So here you are given 1 point. So you can define the equation of a line by saying it is passing through this point and parallel to another line. Then only you can draw the equation of a line. Or if you are given the 2 points, then you can easily write. Okay, like you know that x minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, and here you can additionally z, like I was telling yesterday, na? If you are given 2 points, how to write the equation of a line?
In 2D.
In 2D it is x minus x1 by x2 minus x1 is equal to y minus y1 divided by y2 minus y1. If it is 3D, you will just add z minus z1 by z2 minus z1. So knowing 2 different points, you can write the equation of a line. Now another one is knowing 1 point and when it is parallel to another line, also you can write the equation of a line. So this is another way of writing the equation of a line. Okay. So let us go to the next point. So this can be a numerical in your JEE or in your PU exam. It can be, okay?
Yes.
It can be. So you should know how to find out LM and N. Once you find LM and N, x minus x1 by L, y minus y1 by M, z minus z1 by N. Okay. Earlier it used to be x2 minus x1, y2 minus y1, z2 minus z1. Here it is L minus L, M and N.
Because vector is given.
Vector is there. Okay, so this is important. So now, so equation of a line passing through 2 given points. Okay. So this I have already told. I will write it again. Equation. So one we have already completed. Equation of a line passing through
A point and parallel.
through a point and parallel to a vector and parallel to a vector. We are done with it. Okay. We are done with it. So next, equation of a line
Passing through 2 points.
passing through 2 points. That is also possible. Passing through 2 points. So that's very
Similar to
easy.
2D.
That is very easy. It is similar to 2D. So without going into derivation, let me write the equation. Okay. It is, I have already told the previous to this, x minus x1. So you know equation of a line means you should always have x, y or x, y, z. If it is 2D, x, y. If it is 3D, x, y, z. These are the unknown. So if you know, if you write it in terms of x, y, z, anyone will give you, this is the coordinate of 2 points. You write the equation. Okay. So x minus x1 by x2 minus x1. Okay. Then y minus y1 divided by y2 minus y1. And then z minus z1 divided by z2 minus z1. This is the equation. Okay. So this is the final equation. Okay. These two you need to remember. We need not go into the details of the derivation. It is very easy, but spending time, too much of time is not worth here. Afterwards you can refer and you can do. but not necessary at this stage. You need to, no one will ask the derivation of this. You may be asked the numericals on this. So why numericals? Because if you do a numerical, you can better appreciate the theory. Okay, so you can understand actually what is going on. Okay, so let us just solve one equation. Okay, so let us solve one equation. Let us do one numerical. Okay. Okay. Okay, find the Cartesian form of equation of line passing through minus, so point P1 is equal to minus 1, 0, 2. Then another point P2 is equal to 3, 4, 6. Okay. So the question is, find the Cartesian equation of the line. Okay. So you know x1 is, so this one is x1, this one is y1, this one is z1, this one is x2, this one is y2, this one is z2. So knowing this, you can find out what is x1, x plus 1 minus 1. So then x2 minus x1, so 3 plus 1, right? Then y, then you know y1 is equal to 0, then y2 you know 4, y1 you know 0. Then z minus z1, so z1 you know 2, z2 you know 6.
6 minus 2, 4.
So this is the equation of that line. Okay. So these things you can solve actually. So another numerically as given, like let A and B are position vector of point A and B. Okay, so you know A is equal to another numerical I am solving. Okay, this is numerical 1 and numerical 2. So they are saying find the vector equation of a line passing through points this. Okay, so point A, find the equation of a line passing through 2 points.
Okay.
So the passing through the points this, find the vector equation. So what we have done is Cartesian this thing.
Okay.
So how to
Convert that
find the
into
vector? How to find the vector equation? So my point A is minus 1, 0, 2. Okay. My point B is 3, 4, 6. Okay, so these are my 2 points. So I need to write the vector equation. So first I have to write what is my position vector. Okay, so it is nothing but minus 1 into
I cap.
I, minus 1 into I cap, minus 0 into j cap, 2 into k cap. And then my other position vector is 3 I cap, 4 j cap, 6 k cap. Okay, these are my 2 position vector. Okay. Then the vector equation is normally it will be the vector equation V. Normally you can write it as A plus lambda into B minus A. Like that you can write. Just remember this lambda to B
For
minus
vector equation.
A plus lambda into B minus A. So you know your A, and you can find out b minus a and find out the vector. So this equation you remember. So in the vector equation, first vector plus is a lambda into b minus a. Lambda can be any number.
Yeah, understood.
So this is the vector form of the equation. Okay. So now we have completed the this one, example of line passing through 2 points. This is the Cartesian form. Clear?
Yeah.
Okay. So 2 things we have completed. First one we have completed is parallel to this, which is x minus x1 by L, y minus y1 by M, and this is one. Then you take a picture. We will go to the third approach. Okay. Now we will do the angle between 2 lines. How to find the angle between 2 lines? We have almost done in dot product and cross product when we are doing it in 2D. Now when we are doing it in 3D, how to find the angle between 2 lines? Okay. So when we are going to do it in 3D, how to find the angle between 2 lines? So we know that A dot B is equal to magnitude of A, magnitude of B into cos theta, which is a scalar. Similarly, we knew that A cross B is equal to A, magnitude of A, magnitude of B, sin theta into a unit vector that is perpendicular to the plane containing A and B. So cross product is a vector, dot product is a scalar. So using dot product and cross product concept, we have done how to find out the angle between them. That we have done. Now in 3D, so that was 2D we are doing. Now in 3D, how to find the angle. So angle between 2 lines. Okay. So the third one is angle between 2 lines. 2 lines. Okay. So without going much into the derivation, okay, I can say cos theta. So cos theta. Let me draw it in 3D. Okay, let me draw it in 3D plane. Okay. So let me draw it in 3D. So let us say I have one line like this. Okay. Then let us say I can have another line like this. Okay. So these are my 2 lines, and there can be angle theta between these 2 lines.
Okay.
Okay. So I need to find say, let us say this is my line L1. Let us say this is my line L2. So I need to find the angle between these 2 lines. So as usual, so this line L1 can be A1I, A2J, and A3K, like that you can write, right? Cap, right?
Yeah.
And L2 can be written as B1, B1I, B2J, and B3K, right? We can write like this. Right?
Yes.
So now we want to find out the angle, or okay, A1, A2, A3. Okay. So what they did, instead of writing A1, A2, A3, they have written 1 as A1, B1, C1. Right? Let me write it as A1, B1, C1. 1 subscript is line 1, 2 subscript is line 2. So A2, B2 and C2. Correct? Any confusion here?
No, understood.
Okay. So the cos theta angle, we can write it as, like earlier we were writing A dot B, like earlier when we were doing dot product, we had written A dot B divided by A magnitude, B magnitude. This is what we had written for earlier. So the same thing applies here also. So here you will write it as A1, A2. Okay, A dot B is nothing but A1, A2, B1, B2, C1, C2. That is nothing but your A dot V.
Yeah.
And then in the denominator, you know, A magnitude is nothing but A1 square plus B1 square plus C1 square root. Then A2 square plus B2 square plus C2 square root.
Line 1 is A vector, line 2 is B.
B vector.
Okay.
A1 is so then you can take the magnitude of this or whatever. Suppose you find whatever is the magnitude. Not necessarily actually, not necessarily you need to
If you are
take
taking magnitude there, it's
Suppose magnitude, suppose something is coming negative, you need not take magnitude actually. You should give the actual angle,
because
right?
cos theta, yeah.
It need not be magnitude, maybe it is a typo, so that's fine actually. So now you got the angle between two lines, right? You got the angle between two lines. So this is cos theta. So if we solve one typical numerical on this, okay, let us solve a typical numerical on this, okay. So one example is given, okay. Say vector b1 and b2, okay. Let us say vector, okay. So let us say vector b1, angle between vector b1 and b2, okay. So let me say my vector b1 is equal to I plus 2j plus 2k, I plus 2j plus 2k, okay. So this is my vector, okay, one vector. Then my vector b2 is equal to 3i plus 2j plus 6k, 3i plus 2j plus 6k, correct? So now I want to find the angle between these two vectors. So which is nothing but like I can find out, like say cos theta is equal to, let us say 3 plus 4 plus 12, okay. Then 1 square plus 2 square plus 2 square, which is 9, right? Square root 9, right?
Yes.
4 plus 8. Then 3 square is 9, 9 plus 4, 13, 13 plus 36, 49, okay. So this becomes 12 plus 4, 16 plus 3, 19. Then this is 3, this is 7, right? Right?
Yeah. 19
so
by 21.
Cos theta is equal to 19 by 21.
Theta is equal to cos inverse 19.
Theta is equal to cos inverse of 19 by 21. So it is almost 1. Okay. So 19. So theta is equal to cos inverse of 19 by 21. Okay. So and he has another, in a twisted manner, he has found, he has asked the angle between two lines. So he has given the equation in the form of this. One line is x plus 3 by 3. Another line is like this is one line, okay, x plus 3 by 3, x minus 1 by 5, and z plus 3 by 4.
3, 5, and that will be directional.
Z plus 3 by 4. Okay, this is one equation of a line in Cartesian form.
So 3 minus 1, 3 are x1 now.
I'll tell you. Okay, so this is one equation. Then another equation is x plus 1 by 1, and then next is y minus 4 by 1, and z minus 5 by 2. Okay, so this is another equation. Okay, so these are two different equations. So he is asking to find out the angle between these two. So here this is x, this is y minus 1. Okay, so this is x minus x1, y minus 1, and then direction cosines. So in this case, this is x1, y1, and z1. So you can write a vector as 3i plus 1, sorry, minus 3i, minus 3i, because x plus 3 it is.
Okay, okay. Yeah.
Minus 3i plus j plus minus 3k. This is vector number 1. Okay.
Yes.
Then another vector you can write as minus I
plus 4j
and plus 4j
plus 5.
plus 5k. This is vector 2. So knowing this, you know that now A1 is this, B1 is this, C1 is this. A1 is, this is A1, this is B1, B1 is 1 and C1 is 3. B1 is minus 1, sorry.
Yeah.
And then this is A2 is 1, B2 is minus 4, C2 is minus 4. So you replace everything, you will get.
Yeah.
So by direct vector you can find out that is a direct question.
Or they'll give direct
This is a indirect question. So you can look into these numericals and practice. Only by practice you can become perfect. Otherwise just listening here, not looking into what I have taught, not practicing any numerical, you will forget within 5 minutes. That's for sure.
Yeah.
Practice in mathematics, practice is very, very essential. Do at least 10-15 numericals on this in a different ways, then only you can understand the concept. Especially in mathematics, doing more and more numerical will make you perfect. Okay. So this is we have done the
lines.
Angle between two lines. Okay, you take a picture, then we will go to the minimum distance between two lines. Okay. Okay. So we will go to the minimum distance between two lines.
Yes.
So we are done. So I am solving some numericals also on the board. You can refer those numericals also.
Yeah.
Okay, even if you don't, you have to solve, but still you can see these numericals because I am teaching you and explaining you. So if you refer it, you will find it easy. See, in our days, our teacher, whatever they used to teach, we did not have the luxury of recording those things. So we used to follow each and every word that comes from their mouth, and immediately we used to note it down because we did not have the luxury of listening to their recorded version. But now you have that luxury, so make use of that luxury. Okay. And what the teacher teaches, you can correlate it more rather than anything else. So if your teacher has solved some numerical, if you refer to that numerical, it will be much easier to you rather than anything else. So you can use that concept and extrapolate it to your other exercise numericals. Okay, that's why you can see, as compared to any other subject in mathematics, there will be much more exercises as compared to other subjects, right?
Yes.
Because mathematics is more about practice and solving more and more. Okay. Then the third is shortest distance between
Fourth.
two lines. The fourth is shortest distance between two lines. To find out the shortest distance between two lines. See, between two lines, how you know the distance? See, this is one line, okay? This is another line. So how do you know what is the distance? It will vary from point to point. So the shortest distance between those two lines, how to find out? Okay. So if two lines intersect at a point, so here it is intersecting at a point.
After some time.
It will intersect. Parallel lines will somewhere intersect. Then the shortest distance between them is 0. Okay. But at any other point, if you want to find the shortest distance, you have to draw a perpendicular to it.
Yeah.
Okay. So let us say this. Is this perpendicular? No. Okay. So this angle is little bit more than 90 degree. Let us say this is 120 degree. Okay. So let me make it perpendicular. Okay. So let me make it perpendicular. So when this becomes 90 degree, this becomes the shortest distance.
Perpendicular distance is shortest.
Perpendicular distance is the shortest distance. So let me say something like this. Is it a shortest distance? No, because this angle is say 140 or so. So if I make it perpendicular, let us say I will draw a line perpendicular to this. So this distance is the shortest distance. So if let us say this is D2, this is D1, then D1 is less than D2. Right? So that's why it is called the shortest distance.
Yes.
D1 is the perpendicular distance is the shortest distance. But what is the least distance? Because these two lines will somewhere it will try to intersect each other. That means here the distance is 0. We are not talking about dash distance. We are trying to find out the shortest distance at any particular point.
Not at point of intersection.
Not at point of intersection.
There it is 0.
There it is 0. Okay, so again, without going into the details of the derivation, the shortest distance between two lines in Cartesian form is like say distance is a scalar, you know. Okay, so so let us say this is my line, this is another line, this is a point x1, x2. Let us say this is point 1. So this is x1, y1, z1. This is x2, y2, z2. Okay, this is x2, y2, z2. So knowing these 2 points, I can find out the shortest distance between them, which is a perpendicular. Okay, we can
through distance formula.
We can we cannot take 2 points. We can take 1 point and another line. Distance between a point and a line. If you fix both the point, you cannot draw a perpendicular. Distance between a point and line. So you have to draw a perpendicular here. Okay, you draw a perpendicular. So if this is the least distance. Okay, because if you draw it like this, then this is more inclined and it is a bigger distance, right? So this is D1, this is D2. So D1 is less than D2, right?
Yeah.
So this is the perpendicular distance, and the formula for the perpendicular distance, without going much into the derivation, is the magnitude of. First, you have to take the determinant of. Okay, you have studied determinant now. X2 minus x1 and y2 minus y1 and z2 minus z1. Okay, then a1, b1, c1, a2, b2, c2. So this is, you take the determinant of this term.
Okay.
So you know determinant is nothing but a number, right?
Yeah.
That divided by B1, C2, B2, C1. Okay. So you know A1, B1, C1, A2, B2, C2. Okay. So it will become B1, C2, B2, C1 whole square. B1, C2 minus B2, C1 whole square. Okay. This is BC. Similarly, C1, A2 minus C2, A1 whole square, minus then AB. Okay. A1, B2 minus B2, A1 whole square. Okay. So this whole thing square root. This whole thing square root is the minimum distance. So first you have to find a distance between 2 points. Are you sleeping?
No.
Whatever effort I am putting, everything should be 100% converted into result. I'll ask you anytime.
Hmm.
Whatever formulas I have written on the board, I have taken the pictures, you write down in your summary sheet. These are all formulas important. Because this chapter is full of formulas. We cannot derive everything from this thing and we are at this stage when the exam is very near. And no one is going to ask you those derivations also in 3D geometry. Okay? Normally they will ask there are 2 points on these two lines. Point 1 is on this line. Sorry, so okay. Okay, so if we solve one numerical, we will understand it better. Okay, let us solve one numerical. Okay, find the distance between two lines L1 and L2, which vector equations are. Okay, so so V is equal to, okay, so we want to find the distance between two lines whose vector equations are something. Okay, so whose vector equations are I plus j plus k plus lambda into 2i minus j minus k. This is one vector. Then this is another vector of another line. Okay, another vector equation. So 2i plus j minus k plus nu into 3i minus 5j plus 2k. So you want to find the minimum distance.
Lambda b minus a.
So you want to find the minimum distance between these two lines. Okay. So in this case, A you know, B you know. So A plus lambda B in that form they are writing. So okay. Sorry, here, okay, this is x2 minus x1, okay, 2 points, okay, distance, the shortest distance between two lines, x2 minus x1, okay, 2 points. A1, B1, A2, B2, then we have written therefore A1 minus A2 B1 plus B2 magnitude. Okay, so distance is plus, what is this written? Distance is B cross
b1 plus b.
B1 plus B2 dot A1 minus A2. Huh?
This one is b1 plus b2 dot a2 minus a1. This is magnitude of b1 plus b2.
Okay. Okay, so this is the derivation in Cartesian form. There was another form actually we have just skipped. Okay, that form also you have to remember. That is if you have two vectors, okay, b1 and like b1, b2, okay, like you have a1, b1 in terms of, suppose a vector is written in the form of a vector plus lambda into b. This is the way it is being written.
Okay.
So here also it is being written in that way. So b is equal to a1 plus lambda into b1. Then b is equal to a2 vector plus lambda into b2. Okay, so if you are writing your vector in this form, so my question here is also in this form. What I am asking here, this is also in this form.
A plus lambda.
So in that case, the distance is the distance is b1 vector into b2 vector, that cross product. Okay, b vector, then dot a2 vector minus a1 vector. This is the dot product. Okay, these two vector divided by b1 vector into b2 vector. This is the cross product, then magnitude. So this equation is also important. Okay, so this equation is also very important. Okay? So this sometimes they may not ask in this form, sometimes they may ask in this form. Suppose if a vector, two vectors, like a vector 1, vector 2, two vectors are given in this form, you know what is my b1, from this you can find out what is my b2, from this you can find out what is a1, a2 you can find out, then you take the dot product on the top, the cross product on the bottom. So how it is derived, you can refer the book, but you can use this method. Okay. Clear?
Yeah.
Okay. So that is one. Okay. So now today we have covered so many things. Okay. One is equation of
Two equations, one angle, one short
okay.
distance.
Can you repeat what and all you have studied?
Equation of line parallel to a vector passing through a point. Equation of line passing through 2 points. Angle between two lines, and shortest distance between two lines, that is a perpendicular distance.
Okay.
Four things.
So mostly remember these formulas. Try to solve numericals on it, so things will become easier. So we have almost covered 90% of the things in three-dimensional geometry. Only 10% remaining. That is equation of a plane in normal form. That is equation of a plane in normal form. That is just a 5-minute job we can do in the next class. So you can solve a number of numericals on that. Okay. So intercept form of the equation of a plane. Okay. So suppose earlier we were in 2D, we were doing intercept form as like this. So A, let us say this is A, this is B. Okay. So we used to write x by A plus y by B is equal to 1. So equation of a plane in intercept form. So this is equation of a line. Okay. So we want to write equation of a plane in intercept form in 3D. Okay. This is equation of a line. You want to write equation of a plane. So it will be a 3D plane. So it will be something like this. So something like this, something like this. So you want to write it, you want to write the equation of a plane passing through these 3 points. Okay.
Yeah.
So this point. Okay. So in this case, x-axis is this. This is, let us say, x-axis. Let us say this is y-axis. Let us say this is z-axis. So your x-intercept is A, y-intercept is B, z-intercept is C. Okay. So these are so if you want to write the equation of a plane in intercept form, the equation will be x by A, plus y by b plus z by c equal to 1. So earlier it was x by a plus y by b is equal to 1. Now it is this. So
Z
this
is
becomes equation of a plane. Earlier it was equation of a line. So this is equation of a plane. So this is in 3D geometry. How to write a equation of a plane, that is in intercept form. This is called intercept form. Okay. Similarly, we will write the equation of a plane in normal form. Okay. So that is also very simple one. That will just take 5-10 minutes to cover the plane in 3D. Just 10 minutes we will try to cover. So with that we will come to an end of 3D geometry. Then after that we will go into the probability. Okay. What you are asking regarding probability. So plane in another 10 minutes I will cover, and then we will do probability in the next class. Okay.
Yeah.
Thank you.